Strategic modeling simulations use the Monte Carlo method to automatically generate hundreds of what-if scenarios for your model. Each what-if scenario is considered one trial of the simulation. Before running simulations, you must first identify the uncertain inputs in your model. These are called assumptions, and you describe the uncertainty for each one by selecting a probability distribution from a gallery. You then identify the key outputs of interest in your model. These are called forecasts. During each trial of the simulation, random numbers are generated for each of the assumptions according to the range you defined. The model is recalculated, and the output values are retrieved and added to the forecast charts. This process repeats until either the maximum number of trials is reached or until you stop the simulation. In general, the more trials you run in a simulation, the greater the accuracy of the statistics and percentiles information shown in the forecasts. The final forecast chart reflects the combined uncertainty of the assumption cells in the forecast cell. In strategic modeling, two types of simulations are supported. Monte Carlo sampling generates natural, what-if type scenarios where each assumption is sampled randomly. Latin hypercube sampling generates more accurate statistics and percentiles by sampling each assumption more evenly across its range. My model includes accounts used to track several revenue drivers and key expenses impacting the bottom line. I am tasked to examine the profitability of the company's expansion plans to add several more high-end retail stores. My goal is to forecast overall sales for the company in the coming year and the likelihood of achieving certain targets. For uncertain input accounts, my what-if analysis is done by entering different values based on my best guesses. After recalculating data, the updated sales value becomes the new base case for my what-if analysis. Running simulations allows you to visualize scenarios in your model using a range of results, a certainty range, for each uncertain input. To run simulations, you must have modeler permissions. To start, determine key input cells and define them as assumptions. The forecast as a growth rate cell for unit volume contains an uncertain value that drives the value of total sales revenue, an account I want to evaluate. Next, select a distribution type that best represents your knowledge about the uncertain input. The type of distribution you select depends on the conditions surrounding the input. To select the correct probability distribution, evaluate the input in question and list the conditions surrounding this input. Review the descriptions of the probability distributions. As you review the descriptions, look for a distribution that features the conditions you have listed for your input. The probability distribution descriptions for strategic modeling simulation section and the Working with Planning modules documentation describes available distribution types in detail. For unit volume, I'm selecting triangular distribution. Decision makers can use the triangular distribution to describe uncertain inputs when the minimum and maximum are known, but most values will occur around the likeliest point. I'll set the minimum, likeliest, and maximum parameter values based on historical data. This creates a positively skewed distribution. I'll define another assumption, service revenues. This time, I'll select normal distribution. Decision makers can use the normal distribution to describe uncertain inputs such as the inflation rate or periodic returns on assets. The parameters include mean and standard deviation. You specify a fixed value for these assumption parameters. For the maintenance revenue assumption, I'll select uniform distribution because I know the worst and best cases based on past experience. Now, I'll define a forecast cell. Forecast cells are output cells that contain formulas that refer to one or more assumption cells. These are the accounts for which you want to see the effects of the uncertainty. In this case, I'll set it for sales. A forecast chart with a single point estimate is shown. With the forecast set, I can run the simulation. When the simulation runs, random numbers are generated for each of the assumptions. This simulates how different scenarios of values can occur for these variables in the real world. For each scenario, the model is recalculated and the results are shown in the forecast chart. After running the simulation for a few hundred trials, the results start to converge. Below the forecast chart are key metrics. Here's the base case, the worst case, and the best case. This info box shows the probability of reaching or exceeding my base case. I'll add a stretch goal as a second target value. With this information, the company will have a much clearer picture of the chances of success for their expansion plans. The updated chart shows the higher risk of meeting the stretch goal target. The stretch goal displays a 17% chance of reaching this goal. With information from simulations, you can better understand the uncertainty surrounding our strategic plans. To learn more, visit docs.oracle.com.